The triangle inequality theorem says that if we take two sides of a triangle and we add them together, it should always be greater in length than the third side. So if we say this is length x, y, and z, then we know it must be true that if we add together any two sides, it should always be greater than the third. So there's three possibilities for this, because we can pick any two sides. So this is what must hold true if we have a triangle. Now, if one of those things fails, we don't. So why must it be true that two of the sides, when we add them together, must be longer than the third? Well, just run through a scenario in your mind. Let's say that we have this side, and then we take one side and another. If they are unable to close, or if we think about collapsing them in, when they collapse down towards this third side, they should hit, the ends of these two sides should hit each other prior to reaching that third side. So when we collapse it down, we'll see that these two things do not intersect prior to reaching that third side. Now, it needs to be greater than, not greater than or equal to, because they could collapse down to the point where the sum of them, the two sides that are in green and blue, are the same length as that third side. So in order for the figure to be closed, we want it to closed, and for all three sides to exist, we want that any two sides that we choose, when we add them together, is always greater than the third. So that fact can be used to determine whether or not, if you're given three side lengths, you have a triangle. So if I just pick three random side lengths, like 8, 6, and say 12, well, I have three sides here. I could set up the scenario where I pick any two sides and I want to check that all three cases are true. That's fine. And we would see 14 is greater than 12, 18 is greater than 8, and 20 is greater than 6. So in this case, we have a triangle. But the shortcut, when I'm given three sides, just look at the smaller two. Are the smaller two sides greater than the third side? If that's true, well, then you're guaranteed to have a triangle, because adding one of those sides to the longest side is obviously going to be greater than the third. Now, again, it must be greater than. So if it's equal to, if I made this side 14, well, 14 is not greater than 14, and therefore we don't have a triangle. So think of it again, those two sides that you're looking at, that you're adding together, we want to make sure that if we were to collapse them in towards that third side, they intersect each other, or the ends of them hit prior to reaching that third side. And if they were equal to, they wouldn't. They would just collapse down and just be the same length of the third side. So just check the two smallest sides, make sure it's greater than the third side to guarantee you have a triangle if you're given all three. But let's say that you're given two sides and you have to find a possible range of values for the third. So let's say we have 8 and 6, and we don't know the third side. So they say, what could the third side possibly be so that you do have a triangle? Well, there's a number of possibilities, in fact, an infinite amount, but the number of possibilities falls within a specific range, because once it's outside that range, it no longer works. So what we're going to do here is use this theorem and check all the possibilities that could happen to get a range of values. So we're going to say, we know that 8 plus 6 has to be greater than x. We know that 8 plus x will have to be greater than 6, and we know that 6 plus x will have to be greater than 8 in order for us to have a triangle. We have three inequalities here that we can solve for x. So from this first one, we see that x would have to be less than 14. From the second one, we would see that x would have to be greater than -2. And then we would see x would have to be greater than 2. Okay, x obviously has to be greater than -2, so I don't care about this. And from the other two, I can conclude that it would have to be greater than 2 and less than 14 to have a triangle. So this would be my answer. This is my range of values. Anything outside this would not work. So for instance, if we put 1 in for x, something that falls outside that range, how do we check? We take the two smallest. When we add them together, it should be greater than the third. 7 is not greater than 8, so something less than 2 fails, and there's a perfect example. How about greater than 14? So let's say we play 50. Take the two smaller sides, add them together. Is it greater than the third? In this case, no. But if you choose any value within that inequality range that we have, this compound inequality, it would work. So if we take 10, 8 plus 6 is greater than 10. If we put in a 3, 6 and 3 is greater than 8. So something that falls inside that compound inequality will produce a triangle. And that is how you find the range of values that would work. We're going to leverage the fact that this theorem tells us pick any two sides, add them together, should be greater than the third. We have to create all three scenarios to generate the compound inequality that will give us the answer.